Hi guys, my name is Veli. Last time in our conversation, I gave an example of a simulation in COCO. So let's consider that you are given a design project, like they say, they give you a feed. Say you are given a feed stream, so you are given a feed of carbon monoxide, hydrogen, and methane to produce methanol. So let's say you're given a feed of 31% hydrogen, 67% carbon monoxide, and are given 2% methane as an inlet. This is an inlet. So we are told to design a plant that will produce, say, certain moles of methanol. So you've got a reaction. Let's say you've got this reaction of CO plus H2 to form methanol. So you've got that, so it's 2. So it's bad. So let's say this is your reaction. So once you have such, we have to come up with a flow sheet of this process. So normally I would say you will have a reactor. I'm just drawing a rough sketch. So you've got the reactor. So you have a reactor. This reactor can be a plug flow, it can be a CS star, it can be a packed bed, depending on what your literature says. So after the reactor, you have definitely a separator. So you have a separator here. So the separator can be a flash, it can be a distillation column, it can be an absorption column. So depending on your process. So you will have a product. Since the process you are not having 100% conversion of your raw material, so somehow we have to recycle. You have to recycle some of the raw materials for the economics. So also you've got an inlet, so you've got a patch stream. So this is just a rough drawing. Of course, like when you design, you have heat exchangers and so on and so forth. This is just for matters of demonstration. So this is just an overall setup of your flow sheet. So I'll just name my stream. So here I've got stream 1, stream 2, you've got stream 3, you've got stream 4, you've got stream 5, 6, and 7. So you've got a setup like that. So now we have to go to COCO and try to simulate this process. So I will show you on COCO how you go about doing it. So you come to your programs, then all programs, then you look for COCO. So here is COCO. So in COCO, you've got all these icons. So before you start doing your flow sheet, you have to configure the thermodynamics and also configure the reaction network. So for configuration of your thermodynamics, so you will come and here configure T. So you press there, you click there, then it shows you a whole lot of stuff here, but you have to create your own. So press create. So it's methanol production. I'll give you MP just for methanol production. So now I have to come and add my compounds. So here I come and add. So you've got hydrogen. You've got hydrogen. So H2, you press OK, it's added. Then you come and press carbon monoxide, carbon monoxide, you press OK, you can see it's added. Then you come and press methanol, press OK, methanol is added. Then you have to come and also add your methane, your inlet. So you've got your methane, it's added. So now you have to select the equation of state. So for this one I will just choose, you can choose Pen, Robertson, Swab, Redling, Kwang, and so on and so forth. So I'll just take the SRK. So once you are done with that, of that configuration of your thermodynamics, so that this is simply means is the equation that will relate the pressure, volume, temperature, PVT. So I press OK. So you've got now your T, the MP. So you press done. Remember when I started, I said you have to configure two things. Now you have to configure the reaction network. So you come again here, all programs. Here is COCO. Then you come to CON, Cape Open Reaction Network. So we have to configure your reaction. Those are the things, the reaction that will takes place in your reactor. So you create again. So it's MP, methanol production, MP. Then so we've got general compounds reaction. So I've given it its name. So now I come to the compounds again. I add those compounds that I've added before. So I'll add hydrogen, it's added. I add CO, carbon monoxide, it's added. I add methane, CH4, it's added. I add methanol, it's added. So I've added the compounds. Now all my compounds are here. So now I come to reactions, you see. Then I say come to create. So create. So we have to give it an ID. So normally we put a number, reaction 1. So if you've got more than one reaction, so we have reaction 1, 2, 3, and so on and so forth. But in this case, we're just looking at that single reaction that we have. So you press OK. So what is it showing you now? It's showing you this the compounds that I've added: hydrogen, carbon monoxide, methane, and methanol. So now you come here, you enter the stoichiometry. Hydrogen is a reactant, so stoichiometry is 2, so it's -2 for the reactant. So for reactant it's negative, for product is positive. For carbon monoxide we have 1. Methane is not taking part in the reaction, it's an inert, so it will be 0. So methanol, we're producing 1 mole of methanol. So it is an equilibrium reaction. So the phase, it's a vapor phase. So now you come and press OK. So what is it saying? Element balance mismatch for carbon oxygen in reaction. So we've made a mistake. So that's the nice thing about the software, it corrects you. So the mistake is where it's here. Carbon monoxide, it should be -1 as it is a reactant. So the software itself, if you make a simple mistake, it will tell you and to guide you through. So we have fixed it. So because we are reacting 1 mole of carbon monoxide with 2 moles of hydrogen, then we have to put negatives on the reactor. So you press OK. So we are fine. Then you can close this wheel. Now you come now, you want to put now your flow sheet there. So now you come and press COCO. This is where you are going to do your flow sheet, where you're going to put your process flow diagram. So update, say cancel, then we've got the flow sheet. So the flow sheet appears like this. Now you come to settings. So what do you do now? You have to add, so property package, you have to add your T. So remember earlier we had configured MP, so this is MP, then you select. Once you're done with the property package, you come to the reaction package. So you press reaction package, again you add, then you go to select. Remember we have done MP, so you come and select MP. So now we have added T and the reaction network. So now we can start drawing our flow sheet for the simulation. So now remember we've got this flow diagram that we have come with. So normally I sent an article on simulation where they discuss the onion model. So we normally start with the reactor. So it means, remember I've got this as my feed. My feed is here. But on this process flow diagram, I've got the recycling, then I've got stream 2. So I'm going to start with this feed as the feed to the reactor from the simulation software. So now I'm starting now. Here, insert stream, you click and you come and press the stream. Then it says stream 1. So you click now on the stream. So you have to fill in the values. Let's say the pressure to the reactor is 500 kilopascal. So you can change the units here, whether you prefer bar or pascal, but normally we express everything in SI units. So I'll just put the kilopascals. Then let's say the pressure is 500. You can choose N depending on your design. The temperature, let's pick 298 kelvins. So we had a mole fraction of hydrogen of 31%, so 0.31. For carbon monoxide, we had 67%. Methanol in stream 1 in the feed, we don't have methanol in the feed. Then methane, it automatically works it out. Let's say as a basis for calculation, we assume we're feeding 100 kilomoles into the reactor. So we've got 100 kilomoles. So it has worked it out. So you can check the compound flows. You can come and check the phase. The phase is vapor phase. Remember the equation of state. So it used all this to calculate the state of the stream. So vapor composition. So overall properties. So it calculates everything for you. So back to the flow sheet. So now stream 1, we're saying we're feeding this to the reactor. So you come and select reactors. So you've got different kinds of reactors. So it will depend on your process, on your design. Others might have a CSTR, others an equilibrium reactor, fixed convection reactor, PFR, and so on and so forth. So it depends on what you choose. So in this case, I will take a Gibbs reactor because I don't know the K values, the constants, as the other reactors might need. So I will choose a Gibbs reactor. So select Gibbs reactor. So I come and place it there. So now it asks you assign reaction package MP to unit operation Gibbs reactor. So you have to say yes, this is the reaction package that we have configured earlier on. So you join the stream. So you can come here. So if you like, you can put a pressure drop. You see, the temperature was set 300. So you can play around with these values depending on what you want, or what is your design, or what are you trying to optimize. So obviously the reactor, it must have an outlet. So
are you busy at the moment?
Okay, so like we were saying, obviously you've got an outlet stream, the reactor outlet. So you come and join and click. So you've got an outlet, you've got an inlet. So let's come back to the reactor. So you come here, edit, you press edit. So this is where, as I've said earlier on, you can play around with the temperatures, you can play around with the pressure drops, and so on. So I chose it as an isothermal reactor. Other reactors are adiabatic, so you can just play around. So now you've got here, you've got reaction defined by specified compound. Remember, I had defined the reaction package and gave the reactor ID identity as 1. So I come and say reaction package, then we've got vapor, you can choose. So we said ours is a vapor phase. So then you close. Sorry, let's go back again. So we had here the operation as to say isothermal or adiabatic. So from operation you go to reactions. So here you've got this window where you add. This is where you add the reaction that we had configured earlier on. So we say add. So this is the ID that we gave. So if you've got multiple reactions, so you'll have 1, 2, 3, and so on and so forth, depending on your process. So you come and click here and say OK. So it has already added it. So now the reactive compounds is just showing you all that stuff. So now you can come and close. So now you come to this button and run. You see. So we have run everything, has changed color. So it says it's solved at the bottom. We've got 2 warnings. So now we want to look what are those warnings. So you come here and click status. Phases other than the reaction phase are present at the reactor outlet after equilibrium. So they say we've got a multiple phase coming out of the reactor. So then if we had to click on stream 2, so it says we've got a multiple phase, we've got 2 phases, a vapor and a liquid. So it gives you the overall mole fractions. Here you've got the compounds, molar flow rates. So if you want the mass, you can change to kilogram. You see, it changes everything. So it depends on what you want. So I'll revert back to kilomole. So it gives you everything. So you can even change the temperature and see how it varies with the conversion when you look at your feed and what comes out. So you can play around. Also, you can play around also with with the pressure inside the reactor, and look how it affects your feed. So taking it on from here, so since you've got two phases, you see you've got a vapor and a liquid. Let's say you want to separate this, so you'll have to put what? A flash drum. So you come here, you come to separators, then you press flash, then you select, then so when you click a status, because you haven't yet connected any stream, it will tell you not all material ports are connected and so on and stuff. So you can connect it like that. Obviously a flash will have what comes up at the top, so it's the vapor, say connect. Then you've got what comes up at the bottom, the liquid, connect. So you can run it. So you've run the flash and it has changed color, then it tells you the warnings and stuff. So this is a temperature issue. So it shows you the warning in terms of the temperature and stuff like that. So the bottom, as you're expecting, you've got the liquid phase. So you've got these compound flows, you've got those mole fractions. So most of the methanol reports to the bottom stream, and the rest, as you can see, 0.0, methane is 0.0, hydrogen is almost nothing at the bottom. So come the top, it should mostly be the rest of the stuff. Carbon monoxide is at the top, hydrogen, little bit of methanol, and you've got methane there. So like that flash temperature there, so it's not really a perfect separation here where you have a perfect vapor and liquid temp. So all is just the temperature setup. So this is just for matters of showing you like how you go about the simulation. So like if you want to get the perfect separation here, you will just have to play around with the temperatures and the pressure. So now we've got most of the methanol reporting there at the bottom stream, so you've got the rest of the vapor reporting to the top stream, the vapor stream. So remember, you've got a feed which is methane. So for you to avoid build up in the process, you'll have to have a patch, and most of the methane and stuff, it has to most of your carbon monoxide and hydrogen has to go to the feed to minimize wastage of raw material. So we'll have a recycling and also have a patch stream. So how do we put a patch stream? So we have to split stream 3 in this case. So we have to put a splitter there. So separator, sorry, so we've got mixers and splitters. So you come here, you take a split. So you say select, then you've got the splitter there. So you have to mention the split fraction. So show GUI. So this at the split fraction. The pressure drop, let's say, is still 0. So you've got 2 outlets. So you can add or remove outlet depending on your design. So I will say okay in this case. So let me close here, let me join there, then I've got two outlets. Outlet 1, say connect, then outlet 2. Okay, let me change the split. Okay, those report general. So you can just play around there to see. Okay, I wanted to change the split, so I come and double click here. I want to make it 5%. That is outlet 1, that is the page. So the page, which is now this outlet 1, I'm splitting 0.05. Split factor is 0.05. So I close it. So now remember, we have remember our flow sheet. We had that flow sheet. So we've got the feed to the reactor, we've got the flash drum, then the bottom is the product, we've got that stream 5, then we've got the page, then we have the recycling. So what do we do now? So we come back now to our flow sheet. This is how it is. So we can run it like that and see if it runs. So it is running. So we've got the feed, we've got splitted there and that. So what do we do now? So we have to join the stream to stream 1, the recycle. So how do we do that? So we have to add a mixer. So we have to mix this stream and that stream 6 in this case. So we put a mix. So how do we do that? So we come here, so we come to the mixers, then we put up a mix, then say select. So we've got the mixer here. So remember, we have to take this stream, we're putting it here, inlet 1, say connect, then we have to have that stream, we're putting there stream 2. Let's bring it a little bit here, then we take that and put it like that. You see, so we've got the recycling mixed with it, the feed with it, that initial composition that we were given. Then you get a stream that goes to the reactor. So if we can have a look again, now it looks like what we have on paper. So we've got this now, everything is like this. So we can rename the stream to be like this. So we can rename stream 1, we say this one is stream 2, then we say this one is stream 3, then we say that one is stream 4, stream 5, then we say that one is stream 6, then we have that one, sorry, we have that one is stream 7. So we run it now again and see if it runs. So it runs everything, it's okay. So the simulation we have run it, so the whole process we have run it now. So what it does, so what we did, so we had a feed into the reactor, we didn't have all this. Then the simulation software calculated everything based on the temperatures given. Then we had the product. Then we had a flash where we separated the vapor and have much of the ethanol down in stream 4. Then here we had a page. So we're paging out the we have a page to avoid the build-up of the inlet. So what we fit in as the inlet, if we've got 2 moles of inlet coming in, 2 moles must come out, so to be at steady state. So we can just double check. So in stream 6 we've got how many? Methane, we've got 1.99, which is 2. So we can just double check. You see, we've got 2. So like this flow sheet, it has run out, it has converged, and you've got the molar flow rates of every stream, you've got the pressures of every stream. So this is how you will normally do it. So like when you do your design, you've got different designs and stuff, so you just follow the same principle. So this is how you will do it. So if you like, you can change the patch fraction and see how it affects your conversion, if it will change the temperature and pressure and so on and so forth. So that's it for this example. I will continue to show you how you can quickly do maybe if you've got a distillation column, or if you've got one or more than one reaction. Also I will show you when it comes if you've got an absorption column. So thanks.